Chapter 5, Section 3, we're dealing with more than one event. We have two different events that are happening, E and F, and we want to find the probability of E and F. So when we're doing these type of problems, and typically means multiply. In Section 2, for the most part, or meant add. And for Section 3, and means multiply. So if you can say the words or, think add. If you can say the words and, think multiply. So we're just multiplying these two numbers together. The probability of E and the probability of F is 0.36. That's for independent events. Let's look at question number 11. So this one's a little bit more in depth. 92% of computers are classified as ancient. Two computers are chosen at random. What's the probability that both computers are ancient? Well, so we have two computers. I want to have ancient and ancient. So I would have to multiply 0.92 times 0.92 to 4 decimal places, so they want everything. On part B, 9 computers are chosen at random. What's the probability that all 9 computers will be ancient? Well, that's going to get kind of tiring doing 0.92 times 0.92 times 0.92. So why don't I just raise it to the 9th, because I'm multiplying 9 of them together. And to 4 decimal places. Round correctly is 4722. For part C, at least one of the 9 randomly selected computers is cutting edge. So at least one. Now, so at least one means it could be 1 or 2 or 3 or 4, or 5 or 6 or 7 or 8 or 9. So I don't want to find out all those probabilities because that would take a while. But if it's at least one, that's an idea in this chapter, is at least one means not 0. So at least 9 randomly selected computers is cutting edge. Well, let's find out the probability that 0 of them are cutting edge. And then everything else is the complement, right? At least one, so that's 1, 2, 3, 4, 5. And so this number here, this represents 9 that are ancient, which means 0 are cutting edge. So for this particular problem, if I just do 1 minus the 0.4722, I get a 5278. This is the probability of at least one, because it could be more than one, it could be 5, it could be 8, all those different probabilities. At least one will be cutting edge. So, over here. So whenever we're thinking the at least idea, we're really doing a 1 minus the probability of none. And so this is the probability of none being cutting edge because they all were ancient. So at least one that's cutting edge would be 1 minus the probability that none are cutting edge. It would be, I would say, usual that at least one of the 9 are cutting edge, because 52%, 53%, that is not unusual. I'm not doing the 5%, so it would not be usual, sorry. About half of the time you're going to have at least one, so apologies on that.